Hello, my name is Timothy Carlin and welcome to the IOL INTACT webinar. Joining me today is Timothy Winters. We also have Marion Dillon and Michaela Newcomb working behind the scenes. Today we're going to be talking about improving and automating your in-house testing with the IOL INTACT software. This is the second in a series of webinars that we're planning to host approximately quarterly. For each webinar, we'll try to highlight a different feature of the INTACT software, as well as look at the different protocol testing packages that are available. Today we'll be focusing on the upcoming release of IOL INTACT, and we'll also review our newest protocol package, DHCPv6, which is now available. More on that later. We appreciate you joining. You know your time is valuable. We hope to make these lightweight and informative and to get to the point quickly. With that in mind, we have a short agenda that should last around 35 minutes. If you have any questions, feel free to ask them in the chat window at any time. We'll see them and respond directly, as well as queue them up to answer at the end. We won't be taking any questions over audio for this webinar. With that, we'll move on to the agenda. First, we'll provide a brief overview of the upcoming INTACT release, which is number 3260. There are a few changes, features, and bug fixes that we've included in this release that we'll review with you. We'll also talk more in depth about DHCPv6 client package release. This is a new protocol package that we've made available for INTACT, and there's some notes we'd like to share with you about this. Additionally, we'll review with you how you can automate your testing for DHCPv6 by writing a device driver. Lastly, we'll go over some of the certification program updates that you should be aware of as you proceed through testing. Timothy Winters will jump in on the DHCPv section, and I'll talk to you first about the INTACT updates. Again, feel free to ask questions at any time. Marion and Michaela will be collecting those, and we'll get to them in order. So let's take a closer look at the upcoming release of the IOL INTACT software. So the first thing you'll notice as you get the new release of IOL INTACT is that there have been some name changes. We've done a few things here to make it a little bit easier to both identify which component we're speaking of, as well as identifying the architecture that it represents. To start, what we've typically referred to as being the client, the INTACT client, we've renamed as the INTACT application. This will hopefully make it easier to identify going forward which component we're talking about that you'll probably be interacting with as the user and as the tester. The server has often been a pain point, as it could refer to both a hardware or possibly a software. So the tool that resides on the machine directly connected to the DUT will now be known as the INTACT packet generator. Lastly, the license server we've renamed as the license manager. We'll talk more about these tools on the next slide. Here's a picture showing the different components as an architectural diagram. It's important to note this is not how you would necessarily need to connect the different hardware components. Rather, this is just an abstract of the different components. So you'll see the IOL INTACT application is noted in a couple of places here, towards the upper left quadrant and the lower left-hand quadrant. What we're illustrating here is that you can use IOL INTACT from multiple stations to control testings for potentially multiple DUTs. It's a TCP/IP connection to the packet generator. And of course, the INTACT application can connect to one or more packet generators. Of course, the packet generator is running on a machine that is directly connected to the device under test. Way up in the upper left-hand corner, you'll notice the license manager. This is the RLM floating license utility. This is where you'll install your license for the IOL INTACT software, and is this machine that will need to have connectivity to all of the IOL INTACT applications themselves. Again, that's a TCP/IP connection, so any machine that is connected to the license manager can use INTACT. Speaking a little bit about the potential hardware architectures here, this could be seen as a way to run INTACT on 3 different machines. You could run the license manager on a machine separate from the application, which is separate from the packet generator. So for example, the package enter may be a machine sitting in your lab. The application might be running on your laptop or your workstation, and the license manager could be a virtual machine stored somewhere in your IT infrastructure. Another possibility is to run the client in the packet generator, or sorry, the application in the packet generator on the same machine. Again, TCP/IP could certainly be a local host connection. There's no requirement that they be on different machines. One of the things we've made available with this upcoming release is a couple of new virtual machines. They're both intended to be lighter weight. In the past, our virtual machines have been somewhat heavy-handed, a little bit difficult to download and install. We've made two lighter weight VMs, the first one being for the RLM license manager. This one is a Ubuntu machine, and the idea is that this will be a small deployable VM that you can run on your IT infrastructure and reach from anywhere. The second is for the IOL INTACT application. This one is based on CentOS and has a GUI and will make it a little bit easier to get started from scratch if you don't already have your IT infrastructure set up to handle CentOS or the other requirements for the application. Moving on, let's talk about some of the newer features of IOL INTACT. So one of the things we mentioned from our previous webinar, we talked a lot about automation and device drivers. Some of the feedback we got from that was that it was sometimes difficult to understand what script was being executed and when, and what arguments there might be. And although that does come down to documentation, one thing that was very apparent was that if we could log some of that output to the messages window or to the log from in the test result details menu, it would be a bit easier to debug and to develop from. So we've done just that. In this newest release, you'll find that device driver execution logging will allow the script name and the parameters that the script requires. So for example, for IPv6 reboot, you would see printed out in the messages window the IPv6.sh script call, as well as the series of arguments that follows that. For example, a device driver name, the command reboot, DAD, so on and so forth. This will help you know what arguments your script will need to support to do the various functions. Another new feature, or set of features, has to do with the CLI. In our previous release, in the 5.x release series, the CLI was a brand new function. So there are quite a few instances where you'll see the CLI had some errors and maybe it didn't handle them as gracefully as it could have. So we've taken some steps here to handle those errors more gracefully and hopefully protect the user from getting into more trouble. One of those situations had to do with multiple test sessions. The CLI can allow you to run two testings simultaneously, providing you're connected to different DUTs which are configured differently. Once you've started those multiple test sessions, you'll now have ways of viewing which test sessions are running, as well as switching between those test sessions while they're running. Also, you'll be able to close those test sessions. For example, at the conclusion of testing, you'll close out of it from the CLI so that you could review the runs from the GUI. This might help, for example, if you're doing automated regression testing as part of your nightly or weekly runs, and you're not actually looking at the CLI directly. Also, if you happen to still be running testing as you're closing INTACT, it will do its best to warn you and give you the opportunity to close it prior to finishing. The last big change that we'll mention here has to do with the default port number. After many years of sitting on the 5005 port, we thought it was time to update that to a port more appropriate for the packet generator and the application. So the default port number is now 53005, so 50005. This was so that it was, we're using an unassigned port and we won't accidentally stomp on any other programs or applications that might be using the previously assigned port. When we release 3260, you'll be getting updated packages for all of our previous protocol packages with an updated default port number to help with this transition. So moving on to some bug fixes. We heard reports, particularly from our Windows users, regarding device drivers. Being a relatively new feature for Intact, we discovered that we had some heartache here when dealing with the direction of slashes, as I'm sure many of you are familiar with. So we've updated those and made it a little bit better to handle for Windows users. IPv6 prefixes also weren't the best in the configuration window. So we've updated the parsing of that to better handle the IPv6 prefixes themselves. There are also bug fixes to both core conformance and DHCP conformance. One thing I want to note with this release as well, with these changes in bug fixes and specifically the changes for the CLI, is there have been some changes to how we store data internally for Intact. These changes were to both handle exceptional cases a little bit more robustly, as well as to prepare for future Intact changes, which I'll get to in a moment. In doing this, you'll notice that a new file will be created when you start 3260 in a test session or test results folder. This file will be called intactstatus.iir. This file will gradually replace the previous results.iir that you may have noticed. While this will more than likely be a behind-the-scenes change for most of you, what this does mean is that if you, for any reason, might need to switch to an older version of Intact using the same results, you'll see an error. Basically, the new results file format is not backwards compatible. The workaround would be to simply create a new results directory using the old version and create a new results directory for the new version and to switch between them as necessary. I don't expect that you'll need to switch to the old version once you've upgraded, but in some cases you may, particularly if you're debugging an issue on your device or determining if maybe a new script update has changed something. So let's talk about some of those other new features. One of the big behind-the-scenes changes we've made in the IOL INTACT software is support for XML and JSON containers for the transmission and parsing of packets. This is a behind-the-scenes change because what it really allows us to do is to script more appropriately in a way that is a little bit easier for string-based, mostly string-based formats, and particularly to help with the formatting, in this case, of XML and JSON. Future packages, netconf and yang, to name a couple, will require that packets be transmitted to support those particularly strict syntax methods. By making these updates behind the scene, we'll be able to get these packages out to you faster and hopefully with fewer bugs than you might previously see. The next change is the RESTful API. This is something that I know many have asked for when it comes to your regression testing and your nightly runs. We're targeting this for mid-2018, and the changes that I referenced in the status file will directly lead to this and assist us in getting there. When I speak of the RESTful API, what I'm talking about is consolidating the core of the Intact application into a way that can be easily referenced from multiple fronts, be it a GUI, the CLI, or potentially over the network, or possibly even as a web application. Other updates looking forward, will be for IPv6 core packages. IPv6 is now an internet standard in RFC 8200, and also will be adding support for RFC 8201. These are some pretty lightweight changes, but there are some really tricky test cases that you'll want to pay attention to and that we're updating our packages to support. Likewise, IPsec and IPv2 updated the required algorithms list. So these are changes that have been in the works for quite a while. These were RFC 4307 biz and 7321 biz. 4307 biz was recently became in draft status, recently became RFC 8247. Draft 7321 biz is expected to go to RFC very, very shortly. So there'll be package updates coming for those as well to support those changes. So with that, I'd like to hand it over to Tim Winters to talk to us in more detail about DHCPv6. Thank you.
Hi everyone, this is Tim Winters here to walk you guys through INTACT and the current DHCP conformance testing tool that we have here that we're demonstrating today. And then I'm going to go back and talk a little bit about the programs and why this testing might matter to you. So what I have on the screen right now is the newest version of INTACT, which is 3260. The typical window that you would start up on. This is obviously loaded results that I loaded. So in this case, it would just be load, create new, and then the DHCP package. So I've loaded it up here. As you can see, I haven't run many test cases, just a couple before you guys got on. Over here, we have the configuration window, which this is everyone should be familiar with. If you're a new user and haven't used it yet, this is the configuration window for the device under test. So we put the MAC address in, the address of it. DHCP has two variables here. One of them is for how long it takes the device to solicit. You might want to make this value higher if you're running testing manually. It might take you a minute to find the right command, hit enter, all of that stuff. It's automated, you can set that value lower. As Jim pointed out, we have the new port number up here for Vapor. It's Vapor is our server, 5,000 or 3 zeros and a 5 for the new port number. These are the test interfaces from the server, and then the rest is server information. In a minute, I'm going to come back to this, but here's the auto button. And we're going to run the testing manually at first to show how you would run it. And then we're going to show how you would automate it. So you can easily check off the auto button and set it and forget it in that situation. So, so I've got all that set now. For the moment, I'm just going to run the first test case. Over here, I have the message window. As you can see, I didn't check off the button, so it's popping up a little message here. Automation is not set up on this device. And it's waiting for me to transmit a solicit. So that is the command, transmits a solicit. The test case is off and running. In this case, it clearly comes back that automation it got an echo reply. So the test case ran, I was able to run it. In this case, for DHCP, you have to clear out the information. So I'm just going to go ahead and run a release. That takes a minute to run. So while that's in the background running on that machine, you can go into the individual test case. As always, you open it up. This test case is based on both the IPv6 Ready and the US government test programs, which I'll talk about a little bit more in a minute. In this case, you can clearly see the solicit, advertise, echo request, and reply for DHCP. And then the test case requires that an echo request and reply go out. So my implementation over here is just a standard Linux implementation that's running in the background here. So I'm just doing the ISC command here to bring it up and down. More interestingly, so next I'm going to run a release test case, which I think is E. So in this case, it's going to ask me to solicit again, transmit the solicit, and then it's going to, in a second here, ask me to do a release. So in this case, I've manually set in both the addresses. Obviously, as you can see, there are tons of test cases here. It's not a whole lot of fun to run them all, so I'm going to talk a little bit about automation. For a lot of the automated test cases, what we've done is we've created these little labels on the side. So if you click on the client, for example, you can run all these test cases without having automation turned on, and they work perfectly. The other ones we've had here that are clearly marked client confirm, this is for the DHCP confirm message. So in that case, you often, for DHCP, have to find a way to get the device to send a confirm. The standard says, things like rebooting should do it. Typically, we don't see that at the IOL. Typically, what we see is bringing the port up and down does it. So you can typically unplug an interface, plug it back in, make it think that the link has gone and come back, and a client should send a DHCP confirm. So we put that one in here as separate because the manual usually has to be done. Release is another one that we've done correct this way. Ping is also. So these different labels will select all the test cases that include those features. So this is all the test cases that are highlighted are for DHCP release. So as you can see, it would get, having to sit here to watch every test case run would not be particularly fun. So we've created an automation framework that I'm going to talk about next. So over here, we have a little automation script that we run that is, we give you guys as part of our package. It's called, in this case, it's DHCPv6.sh. And it has a set of commands that should be implemented. So in this case, I've already implemented several of them. One of them I didn't implement yet was release. So I'm going to show you guys how we would do that. So here we have a little function that clearly states what the purpose of this is. The first argument can be ignored for your guys' purposes. We use it internally because we have so many devices here. We basically swap them out by expect driver. We don't expect most of our customers to do that. We've had a couple who have actually emulated our setup, and we're perfectly happy to do that with any customer who wants to just follow what we do. We can hand over everything we have. We also have a lot of customers who want to do this in a variety of different ways that aren't expect driven. You know, might be something as SDN driven, netconf, SNMP, whatever you might want to do for configuring your device or your automation setup. So in that case, you can just ignore the first argument. The other two are what really matter. So in this case, I'd set up this release. I call expect, I SSH into my device, and then I need to add the release command. So I'm going to hop back here and just copy and paste this release command that I was running real quick. So as you just go through here, you're just going to, in this case, I've started expect, I spawn into it, and then right here, I send a command, and I expect. So in this case, it's entirely self-contained. You could also, it's a bash script, so you could functionalize this out. For example, you could take the login on everyone and break that out to a different function if you so desired, and then just put in your individual commands. We put the arguments up here and what they stand for. In this case, there's no actual arguments, it's just the actual commands. We have other ones that do have arguments. In particular, in core, we specify interfaces. If you're doing DAD, know which one to interface. So those are all listed very clearly in the documents. So in this case, you save the file. Just to recap, that file comes from the properties window. So over here, I've set this should be the directory that DHCPv6. So there should be a script inside of test scripts, automation scripts is where I've put it in my case. The playlist is where the current thing you're running, and the results is where your current results go. So now I'm going to log in, check off the box here. First, I'm going to run the first test case, and then we'll run the release. So this one should automatically, yeah. So in this case, it automatically goes off, runs the test case, disables DAD. Tim earlier was talking about the individual commands. So in this case, you can actually see the commands as they get called show up on the message windows. This is one of the new features of Intact. They show up on the side windows. So that's so you guys can see exactly what commands you are running at any given time. The last one we're going to go here and run is E, and so that's the release we just implemented. And again, it's over here in the corner calling the individual command. So in this case, right here, you can see it calls the enable, and then in a second, it's going to call the DHCP command for release. So here you can see it's calling the release command, it's firing it off, and then it'll fire a release and run the individual test cases. So that is the automation of Intact. So I'm sure we're going to get some questions about that, but for a minute, I'm just going to back out and show you guys some more about why this matters. So, oops, sorry about that. So the IPv6 test package, it's available for purchase. It's a yearly license that allows you, each license allows you to run simultaneous testing. What we've seen here at the IOL, we've seen a large increase for DHCP testing at the moment. We think a lot of this has to do with there are certain government agencies that are strongly suggesting that DHCP be included, in particular in enterprise type environments where they expect to know exactly what devices are on the network. We know of one or two agencies that actually put it in their default configuration that they want to see that. Intact obviously tests all of those test cases. I'm going to talk a little bit about how IPv6 Ready and US Gov program currently use DHCPv6 because there are several different test cases. If you looked at the labels list, you notice we listed things like stateless DHCP and DHCP with DNS. I'm going to walk through exactly what test cases you have to run for every program. So the US government test program has always had, since the beginning, an option to run Slack or DHCP. We find that most implementations run Slack. We haven't encountered one yet that doesn't run Slack by itself. They can also run as an option DHCP. So in US government's case, that's only the section 1 test cases. So 1.x, all of those test cases apply. DNS options in DHCP, those aren't required. We include those test cases as they're part of Ready Logo, but they're not required for this testing. DHCP stateless support is underneath Slack. If you want to support that, it falls under your Slack requirements. So if you mark off Slack, you can or cannot do DHCP stateless. It's an optional thing you can document on your SDoc. The Ready Logo is slightly different. The Ready Logo allows you to select basically what RFCs you support. So as you can see here, each section has RFCs that it supports. So if you just do 3315 proper, you do section 1. If you want to do 3315 plus the DNS options, that's section 2. If you want to do stateless, that's section 3. We didn't talk about this today, but we also have the PD test cases. PD has become a lot more popular recently because there's several internet drafts the IETF is working on about giving out a large address space to hosts. So you can give out a /64 or /60 to individual devices, large prefix pools that then they can break up. Originally, that draft was really about home gateways or CPE devices and having a requesting and delegating router. We've started to see it a lot more in host, also in virtual environments, where you want to give out large groups of addresses. So section 4 is just straight prefix delegation, and section 5 is DNS plus prefix delegation. So to recap really quick, here's the individual sections that follows. This is for the DHCP logo that is available. So as a requirement, you have to test core, but we do have some customers who go off and get the DHCP logo. This is an opportunity to demonstrate that you support IPv6. So before, I'm sure this is going to show up in some of the questions. We're going to go off and answer some of the questions here in a second that we've had. And so feel free right now to take a moment and write them in. One question I know is going to be on that is, when is this going to be available? So I'm going to leave that up. On the 18th of October, we're going to make 3260 available. We will also have an updated release of the core scripts with any bug fixes and an updated release of DHCP based on all the feedback we've received. So now we're going to go through some of the questions one at a time. So one of the questions we have, if we want to test multiple devices under test, do we have to have multiple packet generators? So if you want to test multiple devices at the same time, you have two options. One is you can have multiple packet generators. We do also support multiple clients connecting to the same packet generator. What I do want to point out here is it's per license. So if you have 2 licenses, you can test 2 devices at the same time. We support either configuration. So the packet generator, if it has 10 interfaces, you could hook it up to 10 different DUTs. You could also have a packet generator per each DUT if you so desired. So you can do either of those configurations. If you have only one license, you can only test one device at a given time. You can obviously switch through them. When that one's done, you could start a different one to answer that follow-up question. So the question was, does the deployable VM hosting application have VNC? It doesn't right now. We haven't put that on. We typically expect people to access the VMs. I mean, those hosts, you could support turning that on. You could deploy them and turn on VNC if you so desired. But currently, right now, we do not, by default, turn on VNC on our VMs. Something we could talk about, or we could help you deploy that if you wanted to. The device driver in this scenario, we had a question about exactly what that applies to. So I'm going to redisplay that really quick, just to remind everybody. The device driver is a script that we give that helps you log into the device. So in this case, in this release, I run expect, and then I SSH into the device under test. And then I get a prompt, I go through and I do this. And then I said, okay, make sure I send the DHCP release. So that is entirely independent of the, so over here, if you look at Ratchet, so I log into Ratchet just like I normally would, and then I send a release packet or a solicit, whatever I would want to transmit. So the device drivers are explicit bash scripts. They sit, in my case, you can see right now I'm running on an Apple laptop. It sits on the client or on the application, Intact's application side, and then it connects into the device under test is how I've set this up. You could set this up in a myriad of ways. We sort of wanted to allow that flexibility, but what it does do is it calls the bash scripts. If you're running Windows, it calls .bat scripts. We can do that as well. You just have to let us know. We have two different sets of scripts that we deploy to deal with that. You run both of those, it executes those individual scripts and runs them on the machine and then connects you to your DUT, however you desire. Oh, we had a question, the DHCP testing model, we didn't put the price in there. It's the same as all of our other licenses. All Intact packages today are $6,000 per individual seat, and then supports through everyone's memberships that work with us. So support, we have a support-only membership. Most of our customers have a full membership with us and use it for submitting devices for testing, but we also include support and training. If you have any questions about individual test cases, why is something failing or not working? In this case, you've noticed I've marked confirm is not supported. In this device, it would not send a confirm message and when the link was brought up and down, so we marked it as not supported. That kind of stuff is where we would work with individual customers to make sure that it works. Let's see. What is required from the DUT to interface with the automation script? In this case, it's connecting from the individual bash script. So it's whatever interface you use to connect to it. So as you saw in here, I just did SSH. We have other ones, for example, that log into a terminal server is a common one we have. We also have in our CE router test cases, they typically do SNMP resets. So they send a reset, in some cases to a power adapter or to the device itself. So in this case, we just send an SNMP reset that causes the device to send a DAD packet or reboot. If you have any other questions about training or such, feel free to contact us. We definitely do individual Zoom meetings with our customers to show them how things are done on the screen. If you have any questions, you can contact intact@iol.unh.edu, and we'll happily set up a time to work with you on setting up. We're a little bit over time. If we have any last questions, we can try to squeeze them in. If we did not get to answer your question on this webinar, we will absolutely get back to you after the webinar. We will email you your question. We got a lot of good questions. We weren't able to get to all of them. So we will make sure that everyone gets a response from us. We have everyone's email who's on here. We'll make sure that they get a response. All right, with that, we're going to end the webinar. I'd like to thank everyone for participating. I'd like to thank Tim Carlin for running the first half of this to talk about the new features, Michaela and Marion for helping us deal with the questions. Thanks, everybody, and we'll be in contact soon.